Okay, so on page something, I gotta get it up myself. The information that matters that is in relation to the inverse sine cosine matters here. So let me snip that in because that's really important here. So I'm gonna snip that in first. And so there's inverse sine is good from minus pi over 2 to pi over 2, meaning you have to give an answer within that interval. Cosine is 0 to pi, so you have to give an answer from there. And then tan inverse is kind of like sine, but you just can't, it just doesn't have those two boundaries, that they're excluded. So we should do these in a reasonable order here. So we'll start with cosine. So it's like the cosine inverse of 1/2. Okay, so to do a problem like this one, you have to know where in the unit circle. You're really asking this question: where is the cosine of theta equal to 1/2? And if you look at your unit circle, that's on that page 3 of that reference sheet. It's where the x value is 1/2. So that happens at pi over 3, comma 5 pi over 3. Those are the only two places. But then you're supposed to say, no, it only works from 0 to pi. You're supposed to recognize that the answer has to be from 0 to pi, which means that the second one doesn't work. This is the correct answer to this question.
Okay.
So we'll do another one here like this. Let me switch colors here. Do you have that unit circle up? So we can just look, you can just look at it. Okay. So I can then ask you, say, okay, well, where is the cosine inverse of square root of 2 over 2? So like the real question I'm asking is where is the cosine of an angle square root of 2 over 2? And the angle, if you go to your unit circle, the angle could be pi over 4 or 7 pi over 4. You skip 3 pi over 4 and 5 pi over 4 because it's negative. Cosine is the x coordinate on the unit circle also. That's not been made clear. But again, because cosine inverse, you have to choose something from 0 to pi. The only answer is pi over 4. Is that clear?
Yeah.
Okay. So cosine is not real interesting because the answer is always whatever it is, choosing the first or the second quadrant. But now let's go to sine. So it would ask, what is the sine inverse of negative 1/2? Okay, so if you go to your unit circle, where is the sine of theta equal to negative 1/2? Where is the y value negative 1/2? And if you look on your unit circle, it's 7 pi over 6 or 11 pi over 6. Do you see those?
Yes.
But inverse sine has to be from, we have to choose something from minus pi over 2 to pi over 2. So first glance, neither of these work, right? Because neither of these are between minus pi over 2 and pi over 2.
Yeah.
Okay, but 11 pi over 6 is that's 11 pi over 6. To get to the same place, you can also go minus pi over 6. So you actually don't want to look at the angle. You want its coterminal angle. If you remember that from earlier in the course, like you don't want that one. You want minus pi over 6. This one is minus 5 pi over 6, but that doesn't help you much either because that's outside of this window. So the answer is minus pi over 6 because it has to be in the first or the fourth quadrant. Okay, so let's do another one. Let's say I want the arc sine of the negative square root of 3 over 2. You go to your unit circle. Where is sine theta equal to the square root of 3 over 2? That's the y value. No, I'm sorry, negative square root of 3 over 2. And that's at 4 pi over 3 or 5 pi over 3. But again, these are both wrong. So 4 pi over 3 is there. It's not. That's in the third quadrant. 5 pi over 3 is good, but it's not between those two limits. So we have to go the other way. We have to get it from here. So you subtract it from 2 pi to get minus pi over 3, and that's your answer. Is this like clear?
Yeah.
Okay. So I can make them harder. I mean, that's what the direction. I mean, that's what you're going to see in your test. You're not going to see these.
Yeah.
You're going to see like, what is the tan inverse of -1? It might be like letter A. So it's really asking, where is the tangent of theta equal to -1? So on your unit circle, that means that x equals -y or y equals -x. It's basically on this line on the unit circle that goes this direction. That's y equals -x. So it's that angle there. Hopefully you see that. That's 3 pi over 4, or it's the one where you go all the way around 7 pi over 4. Do you see that? Is that
Yes.
okay? So I'm asking because that it's critical that if you to do that. So now this also has the constraint that it has to be from minus pi over 2 to pi over 2. So neither of these work as is, right? So, but this again says this suggests it has to be in the first or the fourth quadrant. Well, this 7 pi over 4 is in the fourth quadrant. So how do we get there? Well, we make this minus pi over 4. So how about this one? Where would be the tan inverse of 2 square root 3 over 3? And this one's a little harder. So if you haven't done this yet, and this is kind of off to the side, is you want to do all the ratios. Like there's square root of 3 over 2 over 1/2. There's 1/2 over square root of 3 over 2. And you want to know all these ratios.
Okay. Yes.
Okay. So like, does one of these get you to this? And I completely messed this up. Sorry. Because I was trying to do the second one there. So the second one becomes 1 over the square root of 3, which becomes the square root of 3 over 3. Okay, so you're looking for where this ratio is true. So where on the unit circle is that true? Where y is that value and x is that value? What are the two angles there?
It should be 11 pi over 6.
Check here.
And
We'll see 11 pi over 6. There's a negative, and
I see. So
yeah,
pi over 6, and then
right
or
so they're both they're both negative or both positive.
So then do I have to find the coterminal? Because I don't think there's both negative, then that would be
7,
where is it? 7 pi over 6.
Yes. Okay, so which of those is between minus pi over 2 and pi over 2?
Pi over 6.
Well, obviously the first one, right? Yeah, so there's your answer. Okay, so there's nothing any more difficult than this, than than these questions. So unless you want to do a couple on your own, I mean, that's really it. I mean, it's going to the unit circle, figuring out, you know, now it could be that it's undefined also.
Okay.
But you know, it could also be some, it could be, it's always one value. So where should we go to next?
Let me send over the other unit.
Okay. We can come back to this also. You also sent, what else did you, oh, I mean, we can do a few of these problems also. I mean, I guess that if you want,
Sure, yeah.
it's
I'm just taking pictures of this part. Okay, I just sent 2 more over. It's just like applications of into models and like kind of real world like problems.
okay. Okay, I see you sent some stuff over. Yeah, I mean, we did some problems like this. These are good to do. Okay, so I'll start with 40. Does that
Yeah.
seem okay? Wow, this didn't scale well. Why isn't this doing? Unbelievable. Okay, sorry, just trying to zoom in, and it's like getting worse. All right, not drawn to scale, clearly. All right. All right, a passenger airplane flying out to 10 kilometers, so that's the height, sees 2 towns directly to the east of the plane. The angles of depression are 28 and then 55. How far apart are the towns? So there's actually 2 triangles here. The first one is this, I don't know, and that's not drawn very well, but it's 10. And then this is the 55 degrees. And then 55 is also here, 55 degrees. You could also use this angle up here. You could make this 45 because they have to add up to 90. The second triangle, 10, and then this is 28 degrees. So this is 28 degrees down here. And they want you to find the distance. So they want you to find X in both cases. And from geometry or from earlier in this course, you know that these are the 3 main trig functions that you will use: sine, cosine, and tangent. Which trig function should you use with this angle?
Tangent.
Tangent. So tangent of 55 equals 10 over X. Now you can actually swap positions with the tangent 55 and the x. You can multiply both sides, but you literally just swap those positions. So x is 10 over tangent 55. And you do the same thing over here. You do tangent of 28 equals 10 over x. So x equals 10 over tangent of 28. You get those numbers. This one's going to be bigger than this one. Make sure the mode in your calculator is in degrees. Always check that before you use it, because you will potentially get a really weird answer if you don't, or you might get one that seems reasonable and it's completely wrong because the way it worked in radians. All right, so is that clear how to set that up?
Yeah, and then with those values, do you just subtract them from each other?
Yes, yes,
Okay.
yes. So we did some problems though with Jamie that where you actually had two equations. I'm not seeing that here, but maybe that's part of the next course. I'm not sure.
The one that I found of the two equations, I think we did. It was that like those watchtower ones or the spire
Yes.
tower. We did that
Okay.
one.
All right, so that's that first question that you might see. Is the second one 34 or 35?
It's 32. Is it like the sentence says the bearing from A to B is N 32
Yes.
west? Yeah, it's 32.
Okay. Is that the picture? Yeah, okay. I really struggle with the like this notation, because it's not, oh sorry, this is weird. With the notation of where instead of it saying west of or east of, let me see here, hopefully I can make some sense of this. All right, so the bearing from A to B is north 32 degrees west. I don't know what that means. The surveyor walks 50 meters from A to C, and the bearing is north 68 degrees west. So let me just do a quick Google search to see what that actually means, because I don't remember. What's not clear is like which angle it is, and because it affects the calculation. That's which is why I'm trying to get that before I go further here. From A to B is north 32 degrees west. I've got a similar problem here, and it's okay. So like the way I'm reading this is that if I draw a little Cartesian plane, XY plane here, it's saying that from the north, if you go straight up, this right here is 32 degrees.
So, okay.
Which I'm not sure, which I don't find particularly helpful, but that means this other angle is 58 degrees, but I don't know why that's helpful, because we already know it's 90. So then let's see what else we've got here. So from C, the bearing to B. So if we just go like this again, okay, the bearing is north 68 from west. So you go north and then you hit that's 68 degrees. Which I still don't find particularly helpful, because Okay, so we can find out. Maybe that's what. Okay, so this becomes 22 degrees in here, and these connect to make a triangle. So this is 32. Maybe that's why that's useful. This is 58, and then this is a right triangle in here, so that makes this over here 32.
Yeah.
So then so I'm going to come off to the side here because kind of redraw it because we've got a lot of stuff going on here. So that makes this whole angle here 22 plus 32 or 54 degrees. And then this one is 36 degrees. And once you have those, you can do the rest of the right triangle. You don't have to draw this triangle in here, but you can use this alternate interior stuff if you remember that. But I think this triangle is also kind of helpful. So the main thing is to draw this sort of crosshairs at each vertice and be comfortable with what each of these means. So the first letter tells you like you're going to go up, and then the second letter is either left or right, depending on. It's up because it's N, but the west means to go left, but you go up first, then left. So the answer to find the bearing from A to C. Well, that's interesting. Okay, so from A to C, I guess we need this angle right here.
Yeah.
Okay, so that angle is 32 degrees. So the correct answer for A is you first go east, right? You see how you're going east, and then you go 32 degrees north.
Okay. That makes sense. Yeah.
First letter tells you, which way you kind of start, and the second one is like a rotation. There's other answers though, like another correct answer for A is north, and then you rotate 58 degrees to the east.
Okay. Okay.
So which is right? I don't know. They're kind of the same. Would assume your instructor would be okay with both. Don't know. But yeah, this is a little more complicated, I guess, than at first glance. It's where you just put the numbers in and you multiply and you go. So maybe replicate this or watch the video later on this one. Okay. Yeah, I guess that takes care of those two types of questions. So some things here you need in your toolbox. You need the Pythagorean theorem. That's a squared plus b squared equals c squared. Okay. You need to know the 6 trig functions: sine, cosine, tangent, secant, cosecant, cotangent. You need to know your unit circle. Okay. And with the unit circle, you need to know that x is cosine and y is sine. And then we talked about earlier, you need to know your inverse trig functions. Is graphing on this exam?
Yes, I think a little bit.
Graphing could be the hardest part. I'm not sure. Okay. Let me look for honors pre-calculus trigonometry test. Let's see if I can find something here that's tough. Okay. Yeah, here's this is kind of related to what we did earlier. This seems like maybe something your instructor would give you. Okay. All right, so here's kind of problem number 1 I found. Do you have any idea how to start this?
Well, with our cosine
Yes,
is like just basically, is that like a different way to write like cosine -1/5/6?
it is. Cosine
Okay,
theta.
so it's the same thing.
The problem is though, is this is not a nice,
Yeah.
so you have to actually make a triangle here. So this is 5 and this is 6. Okay, so this is the square root of 36. I'm sorry, this is 36 when you square it. This is 5 when you square it. So this side right here becomes the square root of 36 minus 25, or the square root of 11. Okay, but pi over 2 is, so the point, I guess the point is that this doesn't work out nicely at all. So why did they give this to you? Oh, you know what? I'm sorry. They're doing something here. They're using double angle formulas, or I'm sorry, some formulas here. You probably have not done that yet.
Not yet.
Okay, I apologize. That is out of scope here for this. Okay, let me try that one here. Oops. No, no, no. Nope. Okay, you said some graphings are here. Let me throw up a graphing problem and we'll see if this is something you're comfortable with, so we can do more examples if we need. So they want you to graph cosine of 4 theta minus 2. They should have put parentheses in, but since they didn't, we're going to assume that.
So
Okay,
then,
so let's go through, and these are important here. I actually prefer you to do period, phase shift, then amplitude, then vertical shift in terms of like order. The period is 2 pi over
4.
4. Good. So that's pi over 2. There is no phase shift. So a cosine starts, and I like to graph these two first, and then we'll add in the next. Okay, so the period is pi over 2. So that means like one period is pi over 2. So it's going to start and it's going to end there. So we need the midpoint of that. And then we need the other two midpoints. So maybe it's a little harder with these denominators, but like the jump here is actually pi over 8 each time, because pi over 8 plus pi over 8 gets just pi over 4. So this is the one that's a little awkward. It's 3 pi over 8. So you should be able to do that. And then when you graph it, I need to shift all of these down. Okay, so now you start at 1 and -1, and your cosine has these 5 points on it. So we get a nice cosine curve here, like that. But it wants us to graph 2 periods usually. Is that what your instructor said?
I think so.
Okay, so I would tell you to keep going to the right. I would not mess with the left, but you have to tell me here if you think that's what the instructor would do.
I don't know if she cares which
Okay,
one.
so we got to go to another other period. So that makes this pi. Okay, because you're doubling pi over 2. So then we got to find the midpoint. That's 3 pi over 4, 3/4. And then you got to find this midpoint and this midpoint. They're going up by pi over 8. So that's what I was trying to say here. Like this next one is 2 pi over 8, 3 pi over 8, 4 pi over 8. This one is 5 pi over 8. 6 pi over 8 reduces to that, but then it's 7 pi over 8. So you actually try to go up by the width of that. And then you draw your 5 points again. Okay, so what we have done here is we have taken care of this box here. Okay, now we're going to take care of the vertical shift and the amplitude. So the amplitude is 1, and the vertical shift is down 2. Is that okay from this? Niko?
Yes, so then just just go down to with
Go
the
down
regular
to,
graph.
so yeah, so I
Okay.
did, like, this is, they didn't give you much room here, but yeah, so every point goes down to, so you do want to label that like this, you want to get this down to -3. So there you go, boom, boom, and you can do one at a time, but then you got to get the other one.
Okay.
All right, so let's look at another question here, where you have to just extract the information that we just talked about, but they're a little bit more complicated. So this one, when there's a bunch of stuff going on inside parentheses here, you want to factor. And this is a little awkward because you're not used to doing it, but this one isn't too bad. Hopefully you can see that it becomes +1. And yeah, it's truly written like this, where the pi/2 is there and the cosine is there. You could add another parentheses if you wanted, if that's helpful. It doesn't really matter, but you need this pi/2. You need this, like, whatever's in front of x, you factor out. There has to be a 1 in front of the x. That's key here. So your amplitude is 2 pi over b. Your b is pi/2, and you do want to simplify that. So your amplitude is 4. Oops, your period is, sorry, that's all wrong. It goes right there. Now it's right. Your amplitude, don't do the amplitude first, do the period first. Your phase shift, that's why you do this factored form here, because your phase shift is 1 left, or -1. And you can see that right there.
Okay.
Amplitude is 4, and your vertical shift is down 3 or -3, whatever you prefer on that one.
Okay.
All right, so if you think you understood that one, try this one here. And I'm going to just add a small wrinkle to it. Let's make this 2 theta right there.
Okay.
So this time you're going to want to factor out a 2, but go ahead and try that one and see, give you 30 seconds here, see your minute, see what you get. How are you doing on that one?
I think I finished, just want to check.
Okay, so this becomes theta plus pi over 4. That's kind of like the little wrinkle there. Like you almost have to multiply in to make sure you get back to that. So your period is 2 pi over 2. Your phase shift is pi over 4 left, or minus pi over 4. You have to be careful here. Like I'm okay with either of these, but your instructor may prefer like saying left or right. The amplitude is 3 and the vertical shift is 4, or up 4 on that one.
Can you explain the phase shift again?
Yeah, so see how it's theta plus pi over 4 here?
Yes.
If it were in a quadratic, x plus 4, you would tell me that this is 4 left.
Okay.
And that's why, and if it was x minus 4 squared, you would tell me that it's 4 right, because you know this really well. The same rules apply here. This is pi over 4 left because it's plus. It's weird, you know, it's backwards. I don't know.
Yeah,
It's
yeah,
not whoever came up with that. That's the way it is. So, and that's what I'm looking for. Like, but I'm not grading it. So you got to go with like go back to your notes, go back to your PowerPoints, you know, ask a friend, like, what is the instructor looking for on that? Now, the kind of related to this, and this is, it's worth discussing, is that tangent and cotangent have a different period. So sine, cosine, secant, and cosecant, they all have a period of 2 pi over b. But tangent and cotangent, they have a period. Put this down here. Tangent and cotangent, their period is pi over b.
Okay.
So in this first problem here, it's pi over 2 because there's a 2 right there. Does this first one have a phase shift? Like, are you adding or subtracting anything inside parentheses?
No.
No. The amplitude is the absolute value of -3 or 3. And the vertical shift is 0 because you're not adding anything to it.
Okay.
So these, you know, these aren't as interesting here, but the period for this next one is pi over 1 because there's a 1 out in front. The amplitude is 1/2. The phase shift is 0 because there's nothing going on inside parentheses here. The vertical shift is 1 because you're adding 1 to it.
Okay, got it.
All right. What else kind of comes to mind here?
Those two things are really it. I think I understand everything else.
Okay, we've got some time left. I can provide practice problems. We can stop here. What would you like to do?
A practice problem works.
Okay,
It's fine.
so let's do these first 3. These are just unit circle lookups. Okay. And do you think you can do this without the unit circle, or is that still like a goal of yours to learn it tonight before the test?
I could probably do some of them without the unit circle. Maybe. I think I probably could. I'll try.
So what I okay, so let me give you some hints or help, like how I do it. 3 pi over 4 is this way. Okay, but I don't want that. I want negative. So I'm actually going this way. So where you are in the unit circle is very similar to where you are up here on the unit circle. So this is all I remember. Square root of 2 over 2 over square root of 2 over 2. Now, if I'm down here, they're both negative down here. So it's minus square root of 2 over 2, comma, minus square root of 2 over 2.
Okay.
And that tells you the answer because this is the y value of this. So this is minus square root of 2 over 2. We're not doing inverses, just we're doing regular. So the 7 pi over 6, you got to know where that is. You might know that pi over 6 is right there. So 7 pi over 6 is going to be right there. And there's some between first and the third quadrant, there's a lot that's similar. So notice you're kind of further out on the X, meaning like it's not a half is there-ish. So it must be the square root of 3/2, but since you're going left, it's negative, and since you're going down, it's negative. So that's the point. The point helps you to figure this out. So cosecant is 1/sine. Sine is the y value. So b is 1/-1/2.
Okay.
And just full disclosure, I'm not looking at the unit circle as I do this, and but you can do it without looking. You got to figure out, like, am I, am I further away, or am I, because if you go down here, now it's flipped because you're kind of halfway, but you're more on the y. If that makes sense, like the y, it's almost a 1. So maybe have you done this here? Like 1/2, obviously that's 0.5. Square root of 2/2 is 0.707, and square root of 3/2 is 0.866. I don't know if you've looked at that in the class, but like that's why in the first quadrant here, when you do your unit circle here, this first point at 30 degrees or pi/6, that's 1. Do you see how this has to be closer to 1? That's why the x value is square root of 3/2. It's closer to 1, like its distance. And then the y, this isn't drawn real well, but it's 1/2, kind of halfway. But when you get all the way up here at 60,
Okay.
it switches because the y is now closer to 1. Well, the y is square root of 3/2, and the x is 1/2. And then right in the middle, they're the same.
That makes a lot more sense.
Great. What else can I have you do? We'll do another word problem here. In a sightseeing boat near the base of the Horseshoe Fall, sorry, moving that around, at Niagara Falls, a passenger estimates the angle of elevation to the top of the falls to be 30 degrees. Okay, so where is that angle in this picture?
It's that bottom right
Yes.
angle.
Okay. If the Horseshoe Falls are 173 feet high, what is the total distance from the boat to the base of the falls? So are they asking for B or C in this question?
B.
B. So which trig function would you use?
Tangent.
Tangent of 30 equals 173/B. Okay, good. Here's one more. I think you might have showed me something like this. Okay, a circle has a radius of 7 inches. Find the length of the arc intercepted by a central angle of 240 degrees. So a circle, if you were to go all the way across, that's 180. So this is a little more than that. So it's this all the way around. That's 240 degrees. It's got a radius of 7. So the length of the arc, S, equals r theta, but theta is in radians. So it's 7 times. How do you convert from degrees to radians? Do you remember that?
Pi/180.
There you go. Now this is in inches, and the length of the arc is also in inches. Okay, so you got to be able to reduce this without a calculator. So like the zeros cancel. 24 and 18, they're both divisible by 6, so that's 4 and 3. So you got 28 pi/3 inches. Okay, and if they want the area of the sector, it is pi r squared times the angle times pi/180, or 180/pi. Sorry, anyway, that's not asking for that, so I'm not even dead. All right. Okay, well, good luck on your exam. If you don't if you don't do anything else, please learn your unit circle. That might make the difference.
Okay, perfect. Thank you.
Cool. See you in a few days. Have a
See you in a few
great,
days.
okay, bye now.
Bye.